Hello guys, one of you sent me a message indicating that you have problems finding the resultant when there is more than two forces. The essential idea is the same no matter the number of forces you have. Just have the x and the y components of each of the forces, and then you add up all the x components and add up all the y components. So the resultant force in this problem, F, should be the sum of the x components. I'll write all the x components here. As you can see, the 40 Newton force is vertically upward, so the x component is 0 for this 40 Newton force. And then for this other 40 Newton force, the x component is 40 cos theta, 40 cos 60, right? 40 cos 60. So I'll have plus 40 cos 60 plus, for this 20 Newton force, the x component, this angle is 60. So the x component is this, which is 20 cos 60. But you see it's in the negative direction, so it's in the negative x direction. So you also have to consider direction, right? If this is positive x, then this is negative x. So this should be minus, so minus 20 cos 60. And then for this other 60 Newton force, the x component is also negative, and it is negative 60 cos 30, right? So minus 60 cos 30. Now for the y components of the forces, the 40 Newton force, the y component is 40. It's just 40 since the x component is 0. You see, it's vertical. So plus the y component of this force is downward this way, and the value is 40 sine 60. If this is 40 cos 60, this should be 40 sine 60. So you have 40 sine 60 excuse me please, this should be negative because it's in the negative y direction. It's in the negative y direction, so this component is negative. And then for the 20 Newton force, you also have, it's in the negative y direction as well, and it's 20 sine 60, so minus 20 sine 60. And also for the 60 Newton force, the y component is also in the negative y direction, right? And it is 60 sine 30 minus 60 sine 30. Okay, that is it. Is there any other force? No. So I guess we are done here. So this will give you 0 plus 40 cos 60 is 1/2. So you will have 20. 0 plus 20 cos 60 is 1/2. So 0 plus 20, and this is 20 cos 60. Cos 60 is 1/2, so minus 10 minus 60 cos 30 is root 3 over 2. So you have 60 root 3 over 2. And for the y component, you should have 40 sine 60 is root 3 over 2, so minus 40 root 3 over 2 minus 20 root 3 over 2, and sine 30 is 1/2 minus 60 times 1/2 is 30. Right? So you can sum these forces. So you should get the y component should be 10 minus 30 root 3. You can simplify, and the x component is 40 minus 30 is also 10. And we have here 20 root 3, 20 negative 20 root 3 minus 10 root 3, so it's minus 30 root 3. So the x component is 10 minus 30 root 3, and the y component is 10 minus 30 root 3. That is exactly what the question was asking you to determine. It said you should show that the x and y components of the resultant force are equal. Hence, determine the direction of the resultant force. So I'll say that x component, I'll conclude here. So F in the x component is 10 minus 30 root 3, and the resultant in the y component is 10 minus 30 root 3. Then I'll say they are equal, and then I say that's quite easily done. Put a right Durant stratum. And so we are asked to determine the direction of the resultant force. First of all, you have to ask yourself, 10 minus 30 root 3, is it in which direction? So you have to find the quadrant. Is it in the first quadrant? Is it like this? Is 10 minus 30 root 3 here or here? In other words, is it positive or negative? So if these two are both positive, then your force should be in this quadrant, right? If they are both negative, then it should be in this quadrant, right? So I will now calculate 10 minus 30 root 3. Let me do the quick calculation here. 10 minus 30 root 3. It is negative 41. It is negative 41. Of course, it should be negative. So it means that your resultant force is here. So this is F. And so now you can calculate any of these angles, this one or this one. Since these two forces are the same, since the fx and fy are the same, it means that this length and this length are the same. So this angle must be 45 degrees. And this must be 45 degrees. Right? So I will say that direction is 45 degrees below the negative y-axis. Okay, you can also say below the negative x-axis. You can also say it is 45 degrees to the left of the negative y-axis. And also, you can just say that direction is, just give this angle is also okay. So it's 180 plus 45. So direction is 125 degrees from the positive x-axis. If you also give your direction as this angle is also fine, you can also give this angle. You say direction is 180 minus 45. So 100 and negative, this was 225. I'm sorry. Direction was 225 degrees from the positive x-axis. Direction is negative 135 degrees. If you just say 135 degrees from the positive x-axis, it's also okay. But even if you just say direction is negative 135 degrees, we'll understand it's from this x-axis. But there's a problem there, because sometimes somebody can give this angle here. They can say that at a bearing, they can tell you that the direction is a bearing. At a bearing of what is this angle? 225 degrees. 225 degrees bearing. Remember, when we use the word bearing, we are measuring the angle from the positive x-axis, y-axis. Okay? So we have solved this problem for 4 forces. Remember, for any number of forces, you would have the same method. Just sum up all the x and all the y. So for this other problem, it should be exactly the same thing. You just resolve each of the forces in the x and y directions. Okay? No matter the number of forces, it's exactly the same way to solve them. Okay? Thank you.